Okay, so yeah, we'll start with this week's question. So, how was this week's question?
They were pretty straightforward, nothing too tricky,
Yeah.
like nothing ambiguous like the previous ones.
Mm, okay. Yeah. So, like for the first one, which of the following statements are true? So, a model-based learner needs an optimal policy given a model of the state. A passive learner returns a policy to be requires a policy to be fed to it. A strong simulator can jump to any part of the state to begin a simulation, and an active learner learns the optimal policy and also decides which action to take next. So this was already pretty much covered in the lecture, but yeah,
So A isn't A correct? Option A.
The option.
model-based learner learns the optimal policy
It was
given
told by professor in the lecture.
about this.
Yeah, the first statement.
The professor said like the model-based learner learns the model, not that the model is given.
Okay, let me just pull the PDF. Desktop. What? Desktop is empty? No, right? Acha. Okay, then it should be in the downloads. Just give me a minute. I'll yeah. So we are talking about model-based learning, right? Learn an initial model M0. That's how it starts, and then loop. Like either you do value iteration or you do polyiteration on the model to compute a policy, execute a policy to generate the data, and learn a better model. So it says learns the optimal policy. So you are not given a model, right? You have to learn the model also. It says learns optimal policy given a model, but that is not true. You are not given the transition model, and you are not given the. So you like based on the model, you compute the policy and then execute it. So is it clear now that given a model of the state space, that is not true because you are also estimating the model of the state space, and then based on that you learn the policy.
Like if the
Okay.
model is given, like why do we even need to learn anything? If model is given, it's basically Bayesian network problem.
So okay, let this so exploration is very less. Maybe these are current knowledge to get the. But yeah, in the slide itself, it is saying that for model-based RL, learn an initial model M0. So you are not given a model, and you have to start with that. Hmm. Now coming to the second question. So we'll just copy this into Jamboard. Okay. So suppose you are performing a model-based passive learning according to a given policy. Now, following this policy, you have reached state A of total of 100 times, and you have four possible actions. You have four possible transitions to the next state, A, B, C, and D. The policy stipulates that you take the action at this state. Given as a action at this, taking action A, you end up A 61 times, B 22 times, and C 17 times. But there is no transition to D. Now it says that assume add one smoothing. What is the value of T A comma B? Okay, so T of A comma B will be equal to number of times you end up on B divided by total total number of samples that you have, right? So, and we are doing, since we are doing advanced smoothing, so we will do this plus 1 and divide the denominator by 4, right? Since in advanced smoothing we have to do this, like if we are estimating if the numerator is m and the total is n, we do m plus 1 divided by n plus the total possible things that we have. So n plus like mod v, in case we are trying to estimate the number of words that we will generate, and where v is the vocab size. So in this case, the total number of basically the total number of states where you can end up is 4. So that's why we are doing number of samples plus 4. So this will be 100 plus 4, and number of times we end up on B is 22. So it will be 22 plus 1. So this is 23 by 104, and you will get it something like 0.221, and that was your answer, 0.221. Now for the next three questions, so question number third says, for the next three questions, consider the following trajectories obtained by running some simulations in an unknown environment given a policy. So the state space is a comma b comma c, and the action space is a comma b. Assume a discount factor of 0.5. Now each sample is represented as state, action, reward, next state. So an example like this was discussed in the lecture. So if you remember this question, let me let me just take you there. Um, where would it be? Where would it be? SF model try learning. Yeah, if you remember this particular question. So here, what we actually, in this case, the discount factor was 1. So we kept on adding the rewards that we got till we got to the end of the simulation, which in this case was a4, 100. So similar to this, but we have a discount factor of 0.5, right? So we will have for run one, the total reward that we got is 0. For for run two, sorry, give me a minute. Yeah. So for run one, the total reward that we have is 0. For run two, it is also 0, because the simulation starts from A and then we get to B with the reward 0. So for run two, it is 0, right? In run 3, there is no occurrence of A, so we will not consider this. Run 4, also the reward is 0. And in run 5, we have the reward as 0 plus 0.5 times minus 1, because we have the discount factor as 0.5.
I didn't understand. Can you repeat?
Yeah. So in the question that was, sorry.
For run 5.
Yeah. I'm just coming to that. Yeah. So here, if you remember, in this question, you were given that the discount factor is 1, right? So if your discount factor is 1, what you will do, you will just keep on adding the values till you reach to the end of the simulation, right? So you, in this case, you were asked to estimate the v pi of b1, right? So v pi of b1 is minus 1 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 minus 1. So that is 1 2 3 4 5 6 7 8, right? So in the first simulation, it is 92, right? Total reward I get is 92. And in the second simulation, we get 1 2 3 4 and minus 100. So this is minus 104, right? So in the second time I reach b1, what is the reward I get? It is minus 104. So my average is 92 minus 104 divided by 2, that is minus 6. But in our case, the discount factor is not 1, it is 0.5. So for the first reward, we will consider it as 0, because that is the first step, 0. And for the second reward, we will multiply it with the discount factor that we will have, and we will multiply it with the reward that we get at that particular step. So it is 0 plus minus 1 times 0.5.
Why not for run 2 then?
Huh?
For run 2, why didn't we consider minus 1 as a reward?
Because we are stated that we want to estimate the v pi of a. So you can also ask a similar question here, right? In here, why did you not start with a1? Why with b1? Because you were estimating that what will happen if we starts with b1. We are not considering anything before b1. We want to simulate what happens when we start with b1. Similarly, the second question that the professor discusses in the class is what is v pi of b2. Now, if you check the simulation table here, you will see that B2 occurs two times, right? B2 first time after B1 and B2 first time after A2. So professor considers both of these instances separately while calculating this value here, right? So for the first time, in first case it is 93, and in first case, second time it is 97, and finally in the third case it is minus 103. So if it is B2, right? So 1, 2, 3, 4, 5, 6, 7. So this the first occurrence of B2 will give you 93, and the second occurrence of B2 will give you 97. So 93 plus 97, and here B2 occurs only once, right? In this case, B2 occurs only once. So it is minus 1, minus 1, minus 1, minus 103. So it will be the average of these three values: 93 plus 97 minus 103 divided by 3, and that is 29. But here the discount factor was 1. It was not anything other than 1. But in our case, since the discount factor is considered as 0.5, we will multiply this we will keep it as 0 plus 0.5 times minus 1. And if it were a third case, then we will do 0.5 squared times the reward that we get here. So these equations are similar to, if you remember this equation that was discussed in the class, like r plus gamma squared r and something like that. So there you will see how it goes. If I can get that slide, let me see. So that is what essentially we are doing here. So do you remember the total reward equation that we saw in one of the lectures previously? Does anyone remember in the active audience? I mean, anyone can answer. Am I disconnected? I don't know.
No, sir. We are doing.
So yeah, I think it was somewhere in this lecture only. Pi n plus 1 is mod s, mod s, mod s. Where is? I think it should be somewhere here only. Gamma, gamma, gamma. Gamma. Yeah. So this one, like reward is R1 plus gamma R2 plus gamma square R3 plus gamma cube R4 and so on. So since this was the second step, right? So since this was the second step, we will just put it as, so R1 was 0, R2 was minus 1. So 0 plus 0.5 times minus 1. And had there been a third step, so we will put 0.5 square times the reward that we might get here. But since in this case we only had like r1 and r2, so r1 was 0 and r2 was minus 1, and we had, okay, let me write like this: r1 was 0 and r2 was minus 1, and we had gamma as 0.5. So therefore the total reward at run 5 will be minus 0.5. And since we had 4 runs, and so the average would be minus 0.5 divided by 4, which is equal to minus 0.125. And that's how you get that answer.
If
Minus 0.
if we had a reward at run 1, then same procedure is applied.
If we,
If we had reward in any of the run except run 5, then means let's say we have reward of minus 1 in run 1.
Hmm. Huh?
So
Then like if we had a reward of -1 in run 1, then it would be minus 1.5 divided by 4. See, essentially what you have to do is you have to you have to just get how the total instances of rewards that you can get, and then take the average of the total. So it's like a calculating expectation, or like calculating the averaging over the total runs that you had. So in run 1 the reward was 0, in run 2 the reward was 0, for run 3 there was no instance of a, so we did not consider it. For run 4 the reward was 0, and for run 5 it was 0 plus 0.5 times -1, because the gamma value was 0.5. So it is minus 0.5. And since there were four cases, so minus 0.5 divided by 4, which is minus 0.125. And that's how we get the value. Is it clear now?
yes,
Now assume that the above samples are fed sequentially to a temporal learner, and assume all values are initialized to 0 and alpha is kept constant at 0.5, and this discount factor assumption is still there, right? What will be the value learned for v pi of a? Okay, so let us solve that one, right? So I'll just copy this. Let's see. And work. So these are now fed sequentially, so there is no concepts of run. So I'll just, this is the first sample that you get. This is the second sample that you get. This is the third sample that you get. This is the fourth sample that you get. This is the fifth sample that you get, and this one, and this one. Okay. And let me put it like this. Okay. So since we are doing TD learning, right? Since we are doing TD learning, so what is the equation that we will follow? We follow NPTEL. So we did solve a question like this in the last lecture, right? Where we saw this question. Uh, so those who did check out the course materials, so it is very similar to what we did in this question. So essentially, we will be following this equation: v pi of, we will be following this equation. So v pi of b is equal to, question. Let me just put it here. So since we are doing TD learning, right? And here we have a comma 0 comma b as the first sample, and everything else is initialized to 0. So we have this gamma as 0.5. This is what you have to remember, right? So here we will take the first sample. So for the first sample, it goes to b, right? So v pi of a will be v pi of a plus alpha, that is alpha is also 0.5, which was mentioned in the question. 0.5 times the reward. So the reward here is 0 plus 0.5 times v pi c. Since all the values are initialized to 0, we will take here 0, and minus v pi of b, which is also minus v pi of a, which is also 0. So ultimately, after taking the first action, we get v pi of a equal to 0 plus 0.5 times 0 plus 0 minus 0. So this entire thing becomes 0, right? So for the first step, we get the v pi of a as 0, right? So we will just note it there. So after doing the first step, we get the v pi of a as 0. Now we will do similar calculation for v pi of c. So v pi of c will be equal to 0 plus 0.5 times minus 1 plus 0.5 times 0 minus 0. So I hope you were able to follow how these values were filled. So just to quickly revise what we just did previously. So the first value is v pi of c, the previous value which is 0, right? Then this is alpha, this is the reward, this is gamma, and this is the v pi of a, which was 0, which we calculated in the previous step. And then we are subtracting the old value of v pi of c from the current sample reward, right? So this will give me minus, sorry, not 0, this will give me uh, this will give me minus 0.5. Okay, this will give me minus 0.5. Now the for the next sample, v pi of a, that is also, that is again v pi of a previously was 0 plus 0.5 times the reward is 0 plus 0.5 times the v pi of b, that is 0, and then we subtract the old value of v pi of a, which is 0. So this entire thing also goes down to 0. So we have calculated for these three samples. Then we start with v pi of c for this sample, right? So this is v pi of c earlier was negative 0.5 plus 0.5 times what is the reward that we get? We get reward as minus 1 plus 0.5 times 0 minus minus 0.5, right? So this will be equal to minus 0.5 plus 0.5 times minus 1 plus 0.5, right? So this will be minus 0.75. Were you able to follow this calculation? If not, you can tell me, then I will just go over how these values were filled in and how we got the final answer. So just for the sake of, okay, so this value was the old v pi of c, this value is alpha, this is the reward that we get at the current time step, which is minus 1. This value is the v pi of b, that is the state we end up in after taking the action. This value is gamma, and this is the old v pi of a, which was v pi of c, which was minus 0.5, right? So after doing this step, we get v pi of c as minus 0.75. Okay, then for this sample, we will do v pi of a. Again, v pi of a is 0 plus 0.5 times the reward is 0 plus 0.5 times v pi of b is 0, and then we do minus minus 0 because v pi of a was initially 0. So again, we get 0. Then we do for this sample a0 comma c. So v pi of a will be 0 plus 0.5 times 0.5 times the reward 0 plus gamma is 0.5. Then we get minus 0.75, which is v pi of c, right? And minus 0. So this is basically 1/4 into minus 0.75, and is approximately minus 0.19, and that is your answer, minus 0.19. Was the calculation clear?
Yes.
Okay. Then it said that we are taking the uh, then it is said that we are giving the same samples to a Q learner, right? We are giving the same samples to a Q learner, and uh, we have to find the value of qa comma a. Assume all q values are initialized to 0. Okay, so all q values are initialized to 0. So I'll just put the initial values here, right? So this will be, so that will mean q a comma a is 0, q a comma b is 0, q b comma a is 0 and q b comma b is 0. Then we have uh, q c comma a is 0 and q c comma b is 0. Why I am doing this? You will understand its importance once we solve the question, right? So we have to first estimate the value of q a comma a, right? So that will be equal to 1 minus alpha times q a comma a plus alpha times what, alpha times the reward plus gamma q star s, so s dash is basically q star s dash, q star of b. That is what q, that is what we will get. So this is basically gamma times, I'll just write the equation more clearly. So gamma times the max over all actions, and q of s dash, that in this case is b, because after taking this action we end up with b, and b comma a dash. So that is what we will use. This is the equation that we will use, right? So this will be equal to, and we have alpha as 0. 0.5 again and gamma as 0. 0.5, right? That is what they have. Yeah, also this is taken from the above question. So discount factor is 0. 0.5 and the learning rate is 0. 0.5. Okay, so then what we will do, so this will be equal to 0.5, 0.5 times qa comma a, so that is qa comma a is 0, right? Plus 0.5 times the reward is 0, gamma is 0.5, and max q b is 0, right? So this will be 0 0 0, so everything is 0, so qa comma a will be 0, right? Then we will do, so is it clear how we got these calculations? Okay, so qa comma a is 0, right? Q a comma a is 0. Then we will start with q of c comma b. Okay, so what is q of c comma b? This will be 0.5 times the old value of q c comma b, that is 0, plus 0.5 times the reward, that is minus 1, plus max of q values of a. So max of q values of a is again 0, so this will be 0, right? And this turns out to be minus 0.5. So qc comma b is now updated to minus 0.5, right? Then q a comma a, this will be, if you feed the values again, it will be 0.5 times 0 plus 1 minus alpha, that is 0.5, reward is again 0, right? Plus gamma is 0.5, and the q star b is 0, right? So this again is 0, so the qa comma stays 0, and we have done till here. Now we do q c comma b again, right? So that will be 0.5 times minus 0.5, right? Because the value of c comma b was updated to minus 0.5, plus 0.5 times the reward that we have is minus 1, plus gamma times the max of all b's, so that is 0, right? So this will be equal to minus 0.25 plus minus 0.5, so this will be minus 0.75, right? Then we have q a comma, then we have q a comma a again, right? So q a comma a, and that takes us to b, so it will be 0.5 times 0 plus 0.5 times the reward plus gamma is 0.5 and the max value of b is 0, so this will be 0. Then we again take qa comma a, and this time it takes us to c, right? So 0.5 times 0.5 times the old value is 0 plus 0.5 times the reward, that is 0, plus gamma times max of C, right? So what is max of all C? So this was then updated to minus 0.75, right? So the max of all C's is 0, right? Because it is 0 and this is minus 0.75.
Yes, yes.
So we
Hmm.
will put it as 0 and again we end up with 0. So Q A comma A is 0. All right. Now, suppose we compute the optimal policies given the current values. What is the action under optimal policy at state C? So, there was one last action regarding QC, right? So, we will finish that. So, QC comma B, that is equal to 0.5 times minus 0.75 plus 0.5 times, so 0.5 times the reward plus gamma times minus 1. So this is 0.5 times 0. So this value is less than 0, right? And we have QCA that is equal to 0. So if we were to make a decision of finding the optimal policy at C, we will obviously pick A. So here we will pick A as the action, right? Because its Q value was more.
Sir, did you discuss question number 3?
Hmm.
Actually, I joined late, so
Mhm. Yeah, this was question number 3. Yeah. So what's your doubt?
no, my doubt was just how you calculated this because I was thinking of calculating V pi B and V pi C. So when I
Yes,
calculated
it
V
is
pi
in
C,
question
it was
number
coming 1.
3. No, no, in question number 3, it is passive, model free passive learning.
Yes, yes.
So why were you computing V pi of C here?
Mm, so the last, it was B pi of A. So to calculate V pi of A, do you require V pi C?
No, no, it is
And
model free. It is model
no, no,
free
model
passive
free I
learning.
understood, but
Mhm.
when you take the formula, na, reward plus then gamma into
No, no, no. So
plus
this is not TD
automatically.
learning or Q learning. It is model free passive learning.
No, I understood, but when you just count the number of rewards, that is minus one plus minus one plus minus one. I mean, you don't require anywhere this VB and VC because
We
these are coming
don't need it.
automatically zero.
Yeah, yeah,
But
we don't need it anywhere. Yeah, we don't
then
need
where
it.
do you use this point 0.5 discount factor?
So this point 0.5 discount factor is used at run 5.
For run 5 because
Huh.
run 5 you get reward as minus 1, right?
Huh. Huh.
And then okay, minus 1 plus what
So
did
this
you do?
is
Point 0.5
0
into
plus 0.5 times minus 1. That's it.
0.5 into minus 1.
Yeah.
Minus 1, right? Yes. Then,
Yeah, that's it. And then so this so at run 1 you get reward 0, run 2 you get reward 0, run 4 you get reward 0, and
yes,
run 5 you get reward as minus 0.5.
that is total. Total is minus 1. I think end of run 5 you are getting 1.
At the end of run 5 I'm getting minus 1, but
Minus
our
1.
simulation started at A, right?
That's fine. But
So the so
A you ended up with C, na? Again,
uh,
then from C to B, you are getting minus one reward.
uh,
Uh, s- so how do you calculate? It is zero, all the zeros plus zero point 0.5 into
minus
V
1.
by C, I think.
No,
And
no,
V
not
by
V
C,
plus C.
automatically it is coming minus one.
No, let me show you this question. So, if you go through the slides,
Hmm.
right, the
Hmm.
professor did a question of model
No,
free learning.
I got that, but there the next state is not given. I mean, that's the problem where here only the next state is given, whereas this is only reward and
No, no,
uh,
no, 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 no. That statement is not correct. Let me see. Uh, Model free. Yeah, if you see this example, right?
yes. Hmm.
Hmm. So there it's like see A1 D minus 1, right? So
Hmm.
A1, if you go down, you will ultimately end up at B1 only, na? So this is not like random generations. So at A1, you take the down action, you go to B. Then from B1, you take the right, you go to B2. Then
Hmm.
from B2, you take the right, you go to B3. Then from
Right.
B3, you take up, you get to A3. Then at
Hmm.
8, then at
But
A3, you take right. So then so in this case, what
in this
happens
case, it
is,
is clear, huh?
so
But
like, what is
in
the
our
problem?
case, where the next state is clearly specified,
Huh.
and there are two samples in one run.
That is fine. You can ignore them. Like they specified the samples only because they wanted to give you this. Later, they wanted to give you as a temporal difference learner and this Q learner question.
No, no, sir. But what is the formula, sir? This is reward plus, I mean, point 0.5, that
Huh.
is the discount
So
factor,
actually,
into reward plus.
no, no, not so. It would go like, if at the first step you get the reward as R1, right? So it would be first step reward. That is, so let me write like in capital. So it
Point
will
0.5.
be R1 plus gamma times R2 plus gamma cube, gamma square R3
Hmm.
plus gamma cube R4 and so on, right?
Hmm. Hmm.
But in every simulation, you had only simulations till two steps. There were no simulations after two steps, right? So we will not consider these things because they essentially did not happen. So in our case, for run one, the reward was zero, right? In run one,
That is okay. Yes.
in run
Run
one, the
one
reward
reward
is
is
zero.
0.
In
Hmm.
run two, the reward is zero because you only did for
Yes,
one step.
exactly. Hmm.
In run four, the reward is zero.
Yes.
In run 5, it is 0 plus 0.5 times minus 1
Acha,
because
okay.
R1
Sir,
is
if you
0
have to
and
find out,
R2 is minus 1 and
hmm.
gamma is 0.5.
Sir, if you have to find out B by B, then,
So
or B by
then,
C, how
yeah,
do you
so then
calculate?
V pi A would be the average of all these values because
Which
that is,
values?
huh?
Average of which values, sir?
Average of all these four values. That's what the professor did in this PDF also, right? He wanted to calculate it V pi B1, right? So what did he do? He got from the first simulation the reward is 92, and the second simulation the reward is
That he added, yes. Because
that he added, and then he
so,
divided by two also, no?
because two times B1 appears,
Yeah,
na?
yeah, and here four times A appeared, one, two, three, and four. So we will
No,
divide
no.
it by four.
My concern is in round 5 first sample,
Uh-huh.
you end up with C, and then the second one it starts with C and then ends up with B. So don't you have to consider here, sir, B by C? I mean,
No, 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 no.
no, no. So,
Here did we, acha, then I can
hmm.
simply ask you this
No, no.
question.
If you have to find out B
Here
by
did we
C in this
calculate V pi
particular
B2?
case,
Acha, then answer me
hmm.
this. Here did we consider V pi B2?
Yeah.
How did we
B2,
consider
yes,
V
yes.
pi?
B2, it is two times.
While computing V pi B1, did we consider any of these intermediate states V pi?
Hmm.
How?
B2 it occurs
Eh?
twice, na, sir.
I'm not asking that. I'm asking that while computing V pi B1, did you consider V pi B2?
No.
Then
But
why
you
are you
added
saying?
all those, but
Then why
you
are you
added all those
saying that?
rewards.
Then why are you saying that we need to consider here? Why should I consider V pi C while computing V pi A?
Because here the next state is clearly specified.
Right? That is specified for the purpose of Q learning and TD learning, right? Ignore them. I would say just
Acha,
ignore them.
okay, sir. If you have to find out in this case B by C, what would be the value? Or
Huh.
B by
Yeah,
B is
then we
0,
can
but B
solve.
by
If you
C?
okay, so if you want to calculate V by C, okay,
Hmm.
right? Then let me just copy these things. We can calculate V by C. It's not a problem. So V by C, right? Since you want to calculate V by C, right? So in the first one there is no V by C, right? And there is no
No.
instance of C.
No.
So this we will not consider. In run
Yes.
2 it will be minus 1 plus 0.5 times 0.
Yes.
In this one it is minus 1. Here here not this is not considered, and here it is C B minus 1. So reward is minus 1. So there is one, two, three instances. So it is
Divided by 3.
minus 1 minus 1 and we
Divided
add
by 3,
these
that comes
and
to
divided
minus 1.
by 3, so this comes to minus 1.
Minus 1.
Huh. And similarly, if you calculate v pi of a, so
Huh,
from
huh.
run 1 it is 0, from
Yes.
run 2 it is 0,
Yes.
from run 3 not
It is
considered,
0.
from
No,
run
run
4 it
3.
is
Oh, okay, run 3 not there. Huh.
not considered, right?
Run 4
Run 4
0.
0, and run
Run
5 it
5
is 0 plus
0
zero point
plus
0.5
point.
times
Yeah.
minus 1.
Oh, here you don't have to take that b pi c. You minus 1 you considered. What I was considering was point 0.5 into b pi c, which comes to minus 1 automatically.
And
That
that,
I was doing. But is it correct or wrong? That's what I
you need
wanted to
not
know.
consider v pi c. Matlab, I would not consider v pi c. I would just keep it as 0.5 times minus 1, and that's it. Because it is model free. You don't, like, you don't know which step you will end up on. It's model free passive learning. You don't need to consider the transition tables. You don't need to consider the like, essentially you don't need to consider the transition table. That's all I would say. So it is independent. So the total reward. So essentially, at the end of the by the end of the simulation, how much did you accumulate? So it is 0 plus 0.5 times minus 1.
Okay, but and b pi b will be 0.
V pi b, because
Or
there are
does it
no
appear?
utterances. So yeah.
Yeah. Okay.
But I would not say that this minus 1 is because of V pi C being minus 1.
No, no, no. I
I
don't know.
would not.
I was just inquiring. I mean, how you got, because all these times it is getting at 0. Na? So all the rewards that A is associated with was 0, and this minus 1 was associated with C. So directly it's not coming. So I was doing it in that way. That way also the answer is same, minus 0.125.
No, actually, they gave you the end state just because they wanted to frame the next two questions, and there they needed the state on which you end, right? Because without that, you cannot do the temporal difference, or you cannot do this Q learning, right?
That's true.
So that's why it was mentioned. Like for the first question, you can ignore because it is model-free passive learning, and we saw
Oh,
this.
then it would be wrong, na, the way I was doing.
I mean, I would say that you did not consider V pi C while computing that.
Okay. Okay, so you can go ahead.
Anyone else would like to comment on whether that strategy would be right or wrong? Like, I mean, you can also jump in the
Like
discussion. Like, it's fine.
actually, in the second question, like question after this, I tried a similar strategy. Um, yeah, for example, in to calculate V pi, I actually tried to first try to like model make create a model of the transition state. Like for example, probability of going to C from A is like 1 by 3 because no, sorry, 1 by 4, because 3 times you go to B and you go 1 time you go to C. And then I use this to like express V pi of A and V pi of B and V pi of C. I know V pi of B is 0 because you're not, you're right. V pi of B, you are the immediate reward is 0, and you are not translating to another state anyway. So I said V pi of B is 0. So the V pi of A only depends on V pi of C, and to I express V pi of C in V pi of A. V pi of C equals to like 1 by 3 1 by 3 V pi of A plus 1 by 2 V pi of B, because some, you see, like 70% of the time it's going to
Oh, yeah, that
right.
from equations it is clear, like V
Yeah,
pi of
and
A.
then I use these two equations to solve themselves and calculate V pi of A and V pi of C.
No, but here it was like,
Yeah, I didn't do it at the end. I changed it at the last moment, but I think it's an interesting approach to solve the problem. No.
hmm. But but that would come on. It's a model free learning. Mein, what do we actually do? So model free is like unknown model, and you just take the like
Yeah, the third
expected.
question, they are not saying model free and anywhere.
In the third question, they're saying, right, using.
So in the third question, it is model free. But when I'm
Okay,
calculating V by
so I'm
C
talking
also,
about question
I'm
number
not
4.
using the model. Na? I'm
No,
simply
you are using
adding
the
up the
model,
rewards
right?
and this.
Because you are using the transition probability, then you are using the model. That's what I was saying. See,
Um,
in the
but
slides,
huh?
it is not asking you to calculate p hat a and e of a. So essentially, you followed this thing, right? Because
Yeah,
you
yeah.
have
No,
to
no,
look at
no.
how many
I didn't
times.
calculate any probability. I simply added the rewards for B pi C. Only thing was I was using B pi C to calculate B pi A because A was ending with zero rewards. And since the second supple in the fifth round was C, so that's why I mean C automatically came into the frame. So that's why I was calculating, but nowhere I used any model. Simply V by C I calculated using the adding of the.
Mhm. No, but essentially, you implicitly using v pi c,
You are
right?
implicitly saying that you can go to
You
C
can go
given
from
A.
A to
You
C.
can't. You don't know that unless you know the model.
Hmm.
How do you know you are going from A to C?
Exactly.
Always.
That's what I was
Like
saying
for
from first.
like maybe you are there is like a going from A to like D or some state. You don't even know these are the exhaustive states, right? These are just examples of the states we have gone
Exactly.
through.
And essentially, when we are doing model free estimation, like we might not even bother considering where we end up, because in the slides they did not explicitly state. And I was just about to discuss this question, right? So here, if you at A3, if you take
But
right,
sorry, this is a
you should
different
end up at.
scenario. No, there are two observing states in this case. It was clearly mentioned.
No, no, but
So this is
just
a
stay
different.
with me. Just stay. So in this example, if you go from A3 to right?
You do not know what the next state is going to be in this case.
Exactly. But so that even if you see till A1 to A3, if you start following the actions, you would say that chain of actions is correct. So from A1, if you take down, you do end up at B1. From B1, if you go to right, you do end up at B2, and B2, if you take a right, you do end up at B3, and B3, if you take an upstate, you end up at A3. But A3, you took a right, but you ended up at A2, which but that should have been absorbing state, right? But these are all simulations, so anything can go wrong. And since something went wrong, instead of ending at actually A4, you ended up at A2. That's what I was saying, that it is not necessary that on taking action A, you actually ended up on action C. This is just for the sake of completeness for the next two questions. They have mentioned that, okay, this is the state where you end up. But if you are doing in a model free thing, I would not even bother considering where I end up, because I'm not learning my probability transitions anywhere. I'm just learning that how much would be my how much is my value. I mean, we can debate more on this once the official
No, 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 it's not a
answer.
question of debate. Actually, actually, sir, if another sample is there in the fifth round, suppose you add one more sample, like
Uh-huh.
starting from C and anything you can do. So in
Uh-huh.
that case, what would be the formula for this?
Yeah,
It
so
will be
that's
0
what
plus 0 plus 0 then?
so it will be 0 plus 0.5 times minus 1 plus
Huh?
0.5 squared times whatever you get there. And if
Okay.
there is one more state, it would be 0.5 cubes times whatever you get there, and so on.
Okay.
It just
Okay.
keeps on. It just
It will
keeps
go by
on
the
discounting
samples.
that one.
Sample.
Huh?
It will go by the sample. I mean, number of sample you have in one
Yeah,
run.
yeah, 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 yeah,
Okay.
yeah. So because you're discounting at that particular step, right? So it will
Hmm.
be gamma to the power n minus one times whatever is the reward at that particular step.
Okay. Okay. Sir. Thanks.
7, 8, 9, 10. So these are all theoretical questions. So which of the following is correct regarding Boltzmann exploration? It focuses more on exploration initially and then on exploitation as the time passes. So this was, I think, discussed in the slides also. ULTZNAN. Yeah. So selection state with a probability, then greedy. So initially we explore, and once we have explored enough, we start exploiting. Right. That is what the entire concept is. So it is similar to like simulated annealing. So At first you want to explore as much as you can, but once you have found an optimal path, you just keep on going down that path, and that's what we are doing. Like, first it is exploration, and then it is exploitation. Then it says it is guaranteed to discover all reachable state from the start state given infinite time. So this is like an asymptotic estimation, and as we have seen in lots of cases previously when we were studying the path based when we were studying the path based thing, that eventually if you give it a lot of time, it will be able to reach all the states which are reachable, right? Then it says it leans more towards exploitation as the temperature is increased.
Just the reverse.
As the temperature is increased, no.
That's the reverse thing. As the temperature decreases, you lean more
Huh.
towards
Yeah.
exploitation.
Yeah.
I mean, exploration is when the temperature is high.
Higher. Yeah. And finally, the probability of an action being choosing at a particular stage varies exponentially with its q value at a point in time, and that is true because that's how we are actually calculating the probabilities, right? So it does depend exponentially on the q value. The next question is which of the following is required for the convergence of Q learning, right? So obviously, very large learning rate will not be the right case, right? And suitable initialization of Q values is not required because we start with zero and still we did find we do find a optimal pattern. All states are visited infinitely often over infinitely many samples, so it's like seeing lots and lots of data so that you converge to an optimal state. And that's what essentially this statement is trying to say, and that is correct. A policy used to generate episodes for for learning should be optimal. No, that is wrong. It should not be optimal, but it should be a proper policy. That is what was discussed in previous lectures as well. Because if we actually start with optimal policies, then we do not even need to do Q learning because
Why
we
we, there's
have
nothing to learn.
optimal values. Exactly. Which of the following statements are correct? If an agent does not perform sufficient exploration in choice of actions at risk of never getting large rewards, yes. If the agent has perfect knowledge of the transition and reward model of the environment, exploration is not needed. That is an obvious thing.
Yeah, no
That's
learning
correct.
is.
Correct. Correct. That's
Yeah,
correct.
because you can directly start exploiting, right?
Yes.
You need
Yes.
not even do. Degree of exploration should be increased as the learning algorithm performs more and more updates. No, it is the
This is
other way
wrong.
around. That the higher you are in the updates, you should be exploiting as much as you have explored. And exploration is not required. That is totally wrong statement.
Both models require exploration, whether it is model based or model free.
I hope others are also able to follow the discussion. If not, you can ask anytime you feel asking. It's fine. And lastly, it's like model-based learning usually requires more parameters to be learned. Model-free can simulate new episodes from past experience, and model-based methods are most sample efficient. So, since it is model-free, new. Achha, there is one comment.
What is the meaning of sample efficient?
That means it
Um,
might require less samples. I mean, that's what I would think. But yeah.
this was described in the lecture. Sample efficiency is essentially like an reaching optimal policy with less number of sample.
Yeah, so someone has raised a hand. Yeah, you can
Uh,
speak. Like, we are just 8 people, so 7 people, 6 people, it's fine. You don't need to raise your hands. You can just unmute yourself and speak. Like, there are not that many people.
So this assignment questions will be asked in the panel exam.
The
The same assignments will be asked in the panel exam.
I I don't know about this. Like, I have no idea what kind of questions you will get. That I
Okay.
really have no idea on. You can ask in the portal in the forum, which wherever that is. I don't even know the
no
links.
one's going to answer. Don't bother.
Actually, I'm just a like I'm not the official team. We are just like taking. We are just told to take the live sessions. for the courses, so we have no idea how the questions are set and who is setting these questions and so on. So there is no communication regarding this. Any other question?
Tomorrow you are starting 12th assignments, right?
12th assignment. So, I mean,
Yeah.
only after its date has passed, right? Because if I give you the solutions now, then it would be unethical, right?
Okay.
So its last date is 23, no, so it's 19th April. So I'll solve it on 20th April.
Okay.
But yeah, we will go over some practice questions. So let me see what I've considered the edge. Consider the following perceptron network, number of edges, and the representation of pointers. Okay, so we do have a question like this. So then we also have a question like this, question like this. Question. Consider the oh Baba, what will be the output given
No,
the?
it's easy actually.
I mean, yeah, it looks heavy, but
No, you just need a calculator,
hmm,
nothing else.
yeah, f of x is sigma. Achha, so you guys are aware of these activation functions, right? Activation functions and their corresponding derivatives.
Yeah, so it was discussed in the lecture.
It was discussed in the lecture. Okay, nice. So then let me just jump to the question. So how were this week's study material? Did you find it easy? Did you find it tough?
I- like there was not much of material actually. Um, like half of it is just dedicated to ethics. The
Hmm.
other half is pretty good, yes, but nothing like too difficult or too, you know, insightful.
So it was just like a. I mean, I think it would be very similar to what Andrew and course on Coursera. If you have
Exactly. Yeah, yeah, yeah. Exactly. But it's just like, you know, like trying to compress 70-hour lecture into one
yeah,
hour.
that's what I felt like. The moment I saw the material, like I was like, they are teaching too much to be consumed in. Anyway,
It is like,
this was right. This was a
Yes, sir. The course is too heavy, I think. I mean, for 12 weeks, for those who do it for the first time,
from here
it's
on.
really
From,
tough.
from here on, the Bayesian learning, like even I was feeling a bit confused in
I mean, how
solving.
do you do this in the exam? I don't understand.
I never took an NPTEL course in my life before. This is my first time that I'm doing it. So
No, no, this one actually, I mean, it appears tough. This is the one which is very tough. I mean, it appears to us tough because this is the first time I'm taking kind of thing. And because you provided that all those materials for this week, that was very helpful. All
yeah,
those
certainly.
on
Without
that,
you, like
yeah,
this course would be a bit more difficult.
yeah. You provided a lot of material which was really helpful.
Not only material, but like explaining the
Yeah,
numerical and stuff.
explaining also. Yes, attending this
Yeah.
problem solving class also. It's only helpful. Otherwise, it would have been a horrible, terrible kind of thing.
thanks for the feedback. Like, yeah, that's great. Okay, cool. So so you might be aware of this concept of linear separability, right? If you've gone through the course.
Yes, yes.
Yeah. So this one, since they have said that they have one hidden layer, so now XOR can also be realized, right? Otherwise, if they had just one neuron, then uh, doing XOR would not be feasible. So it is AND XOR or and OR, and XOR is not linearly separable, but rest all are. So yeah, with one neuron, XOR cannot be realized. But if you have one hidden layer, although they should also mention how many neurons are there in the hidden layer, because I can just say that.
Yeah, like you need infinite neurons in a hidden layer to accomplish uh, no, not ideally. You need only two neurons, right? In hidden layer to accomplish XOR.
Yeah, I mean, I can also do it with
Yeah,
one because I'm given ReLU activation. So there might be an optimal set of parameters using which I can actually learn.
yeah, railway activation is more powerful than the one discussed in the lecture.
In the lecture, you typically see either a threshold based activation, or there is sigmoid, or there is tan H, something like that. These are only the activations that you have, and then yeah, you just use them. But yeah, here it is not just one neuron; it is asking for one hidden layer using ReLU activation. So clearly, you can easily realize all these functions. Now, if gz is tan h, which of the following is the correct derivative for which of the following is correct expression for its derivative with respect to h? So, can anyone tell me what is the uh, function for tan h? What does
I
tan h
mean,
look like? Like,
tan h is like goes from minus infinity to positive infinity as input, and there's like zero to one as output, right?
then I'm
Zero
asking
crossing, zero
how
crossing.
tan h is written. Like if I'm saying tan h of x, what is it? What it is equal to?
I think it is
And
1
as an e
minus
to the
e to
power
the
x
power.
thing.
Yeah, yes,
Yeah,
in
I
terms.
don't remember. I do remember the differentiation is equal to psych square h.
Yeah, so tan hx is e to the power 2x minus 1 upon e to the power 2x plus 1. So it's like sin h of x, that is e to the power x minus e to the power minus x over 2, and cos h of x, that is e to the power x plus e to the power minus x over 2, and if you just divide these two, you get tan h of x, and it is e to the power 2x minus 1 over e to the power 2x plus 1, and its
Sir, why
derivative.
2x? Sir, why 2x? It will be
So
simply e to the power x.
no. So see, it is e to the power x. Uh,
Sin hx by cos hx, no?
Yeah, e to the
So if
power
you
x
divide, then
minus
what it
e
will
to
be?
the power minus x
Divided by,
e
yeah,
to the power x plus
minus
e
x.
to the
That's
power
all.
minus x, right? So
That's
when I
all.
multiply e to the power x in numerator and denominator, so let's say I multiply
Oh, oh, that
e
is
to
the
the
same
power,
as this, right?
so it is e to the power 2x plus e to the power minus x plus x, so this becomes 0, and e to the power 0 is 1, so this value will become 1, and similarly e to the power 2x plus 1.
There should be minus there instead of
Ah,
plus.
yeah. Sometimes the eraser works, sometimes it does not. So it is e to the power 2x minus 1, and so ultimately you get e to the power 2x minus 1 over e to the power 2x plus 1. And if you derive it, you get the expression for sec hx, and that is squared, which is equal to 2 over e to the power x plus e to the power minus x squared. And sec h squared x is also equal to 1 minus 10 h x squared. So that's why it is 1 minus g of z squared, because it said that g of z is 10 h of x at 10 h of z. So whatever is that. This will be minus 2, and this will be 4. Yeah. So did you guys compute these values ever, like before? Have you done these kind of questions like,
Like what differentiation?
I mean,
I mean, yes. I mean, anyone who's like taken 12th maths course has done differentiation.
but like in the frame of reference of this course, like did you try on your own finding these values and actually verifying that 10h square x plus sec x square x is actually equal to 1, and then it becomes 1 minus 10h square x, and that's how you follow, or you just like okay. Anyways, it's fine. It's not needed. So yeah. So differentiation of 10h is sec square x, and sec square x is 1 minus 10h square x, and that's how you get 1 minus gz square. Now, which of the following statements are false about gradient descent? So, when training neural networks, the learning rate is usually chosen by hand. The network does not learn on its own. This is actually a true statement because you need to give the learning rate, right? In stochastic gradient descent, gradients are always positive. That need not be true. In full batch gradient descent, the loss will always decrease after one iteration. That is also not true. It can also increase. And gradient descent in some ways is a local search algorithm. That is indeed true, which we also saw uh, in the previous lectures when we were dealing with when we were dealing in week 4 and week 5 when we were doing the simulated annealing and things like that. There we also saw gradient descent as a way to actually find the
No,
best
but
next.
in the answer they say false. Option number D.
So that's what I'm saying. It is saying that what statements are false. I'm saying first and fourth is
Okay, okay,
true.
okay.
So
False.
second, third is false. Yeah. Because whenever you're doing gradient descent, you're taking a step in the direction of the gradient, right? And your gradient is in your local, is in your neighborhood itself. The state that you will end up is in your neighborhood itself. So you're doing kind of a local search algorithm. Now, suppose we are using a neural network to decide. Uh, I hope you're able to see the screen clearly, right? You can tell me if it is not.
Yeah, yeah, yeah. Yeah, its screen is visible.
Yeah. So suppose we are using a neural network to decide what all objects are present in a given image, which of the following activation is most suitable at various nodes in the output layer, right? So which of the following do you think would give you the correct label? Like since you are doing classification, you need a value between 0 or 1, between 0 and 1, right? So
Softmax, right? On outmost layer, I always do softmax when you are doing probability distribution.
So softmax you will do to get the distribution, like to basically you
Pro-
will do this is that is kind of a normalization that you do, but
right.
activation function is sigmoid, right? Because 10h and ReLU this will not give you a value between 0 and 1. Essentially you want the probabilities that okay, state 0 is this probable, state 1 is this probable, state 2 is this probable, and
So
so on.
in that case, I think softmax is required when
After
it
doing
like
that, when you need to find that which label is most probable, so then you do like softmax, right? To basically do the to basically find the peak in the probability distribution.
okay, actually sigmoid fits for most of the application works or what.
What does the lecture says? Okay, let me see. Have they talked about this in the lecture? I mean, they should have, right? Ethics of AI. Oh, no, I don't need to go that convolution neural networks. CNN. So this is deep reinforcement learning. Okay, I don't want that. Where they might have discussed it. Does anyone know where they might have discussed this? Like maybe you can just quickly go over that, right?
What?
And I'm just asking like uh, where they might have discussed like the labels and all. Does anyone
Uh,
know in which
which
lecture?
labels?
Like how do you get the output? Suppose we are using a neural network, so there might be
It
some
is a lecture one. Last slide.
is in lecture one last slide. Yeah, here. So softmax layer is output layer. So we are representations in 0 to 0. Unfortunately, न्यूरल नेटवर्क तो हो गया ठीक है बट इन एवरी ईयर वन आई हैव अ स्टूडेंट इन बिग फैट लैपटॉप एंड आई आस्क हिम so I am
It was when they're discussing like activation function.
general version of neural network. So ordinarily, we'll put in a sigmoid and if you're not a sigmoid, that we're doing 0 and 1, and y3 we're doing 0 and 1, it will not necessarily, it will not necessarily sum up to 1. So then we take the softmax over this sigmoid values. So if you have seen implementations of neural network, there you will find that softmax is done only after getting the output from the final layer. But at the output layer, the activations that is generally used in classification is sigmoid. Softmax is basically done to get these distribution to sum up to one.
Yeah,
That,
but sir, like once your softmax, the softmax is already taking minus infinity to positive infinity in 0 to 1, right?
but that is done on the output of the final. That is done on the final output. That
So,
uh,
so like the why is the question like asking about the output layer if they are not talking about like the last layer?
yeah, yeah. So see, it is asking which of the following activation function is most suitable at various nodes in the output layer, right? So at output layer, what you will do, so basically you will do softmax at each of those nodes, right? So okay, let me just sketch one neural network, right? So if you have something, so this is your input, then your input goes to like 1, 2, and 3 neurons, and then you have like let's say you have two outputs. So what will be the activation in this layer? This will be sigmoid only, na? Because you want the probabilities to be between 0 and 1, right?
Yeah, but that's what softmax do as well, right?
No.
Softmax also
So
converts it to.
yeah, softmax converts these outputs that you get into a probability distribution. And then from this probability distribution, you pick the one that has the maximum probability. But softmax is not exactly the activation function. The activation is sigmoid. Softmax you apply on top of the sigmoid values that you get, right? You can obviously see. I can also apply softmax to ReLU values, right? Cannot I? Like if the activation if I put here is as ReLU, I mean, I can put everything here as an activation of the output layer, right? No one is going to stop me because ultimately I will do softmax to get the final label. Softmax is essentially done to get the final label. It is not done to like it is not an activation function per se.
Like so, like if the softmax is like the
Acha.
secondary thing, then 10h and ReLU function will work as well, right? If you're
Yeah, yeah,
using
that is
softmax,
fine.
then
That is fine. That's what I was saying. Like, see, it can happen like this is 10, this is 20. I can apply ReLU and I get 10 and 20. But then how will mass distribution look like after softmax? It will be e to the power 10, e to the power 10 plus e to the power 20, and e to the power 20 over e to the power 10 plus e to the power 20. Now these probabilities are adding up to one.
yeah. So what's wrong with this?
So there is nothing wrong. I'm just saying that the question asks which would be more probable. So the most probable would be sigmoid to start with.
I mean, the professor didn't say anything like certain activation function are
Uh,
more suitable for
yeah, yeah.
object detection.
But it is just saying that which of the following equation is most suitable. So between ReLU, tanh and sigmoid, I would prefer ReLU personally, but the question argues sigmoid, and I think the argument is just to state that yeah, the values are between zero. The values will be between 0 and 1 at the output layer. I can put any of these. I can put any of these, and then so I can put a softmax on top of that, right? To get the final label. Essentially, that is what softmax is doing. Like it is just normalizing everything so that you can see
But
that.
Sir, but in neural networks, normally sigmoids are most of the time used. You don't find the use of ReLU. ReLUs are used in mostly
Hidden
in
layers.
deep learning, CNN and other things, I think.
And
I mean,
I have
it's
never.
not seen normally.
this
Uh,
is, and I would not say that I would not think that this is a correct argument, because like anything can be used anywhere.
yeah, right. That's true.
There is no point in saying that this cannot be
Mm-hmm.
used here or like this cannot be used there. And since it is, they are saying that we are using a neural network, so neural network, if it is deep enough, it can be considered like a deep neural network. So
Okay, I got it. I got it. I got it. So, like the softmax, they're only going to decide one object,
yeah,
right? And
exactly.
we are talking about multiple objects in the image. That's why softmax can't be used. And we can't use ReLU and TANH because they don't give probability distribution. Only sigmoid can give detect multiple object and give probability distributions. Yeah.
But using softmax also you can detect multiple,
No,
right?
you can
So
only
I say
detect one object.
no, no.
Softmax,
Yeah.
in the Andrew Trask's book, I read that once you use softmax, the neural network is configured such that only one object is detected,
Huh.
and rest of the objects probability goes down to zero. You can't actually detect multiple
No,
objects
but
with
you take the
softmax.
maximum probability, na? You select the one having maximum probability. So that
No,
way
but
you
we have to
select
select multiple objects as written in the question. Multiple objects are possible. You can't do that with softmax.
Okay, so then let me say that okay, I got e to the power x, right? And if there are multiple objects, like let's say there are like three, okay,
Hmm.
and uh,
You can't have all three have equal to one value, right?
no, no,
If
I'm
you have
not saying that all three are equal to one. See, softmax will just say that one label is more probable than other,
yeah,
like
but for example,
it,
if we have 10 objects,
uh-huh,
about 10 possible objects, and all
uh,
three of them are present, so three nodes value needs to be one, right? Three nodes value needs to be one. You can't
but see,
have that in softmax.
even sigmod will not give you exactly one, right? Because
Yeah, yeah, but it will
sigmoid
tend
looks
to give you.
something like this, right?
Yeah, but if Sigma can give
If
you
it
one,
is,
right?
higher, obviously it will give you one. But what I was about to argue is that okay, still even if you don't apply sigmoid, apply ReLU, do the softmax on top of the ReLU. Anyway,
Yeah,
softmax is not an activation function. I mean, let's be clear with
no,
that.
softmax is the activation function. Softmax is the activation function, I think. They discussed it in the chapter regarding activation function.
But then why I would not differentiate, right? Like unfortunately, if you've seen our computers, there are segments. They may output a number between 0 and 1. They do not have to be normalized to 1. But more importantly, they may not be sigmoids. They may be tannins. They may be ReLU. That's not, they can be anything in the middle, because we cannot marry a certain activation function. Want to create a general version of the neural network. So what we do?
If you look at it, the internet, there's clearly like software is an activation function. For example, in the analytics vidya, they talk about the software activation function. In Wikipedia, they too also talk about software as a normalizing exponential function. Like soft,
Normalizing exponential function. Yeah, that's what I would
yeah.
say.
In Pinecone, they also talk about software activation function. Like y- in Towards data science website, they also talk about software activation function.
Simply saying that you are the max, you are pointing to the max. You're pointing to the max and so on. So that's like a sort of software, it is still monotonic and non-local because the software outputs depend on the GPU. So then let us take a step back. So what would be the problem if I apply softmax in a multi-label setting? Acha, let me see.
Because when you apply softmax, only one object can have a value equal to one, and we are talking about multiple objects.
Uh-huh. So what if instead of picking the first one, I just pick the first two? Then
You can't have that in softmax. In softmax, once you normalize it, only one object can have one value.
no, 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 no. That see here the value is not one for any of these two. We
Yeah,
softmax
it
just
is
basically
one if
normalizes. So it just does like this, so that and then you pick the peak as the output. That is what you do. Nothing else. Softmax does nothing else. It just
yeah,
basically tells you that which of these is most favorable.
Like think about it, sir. Like if, for example, if there are two objects, both
Hmm.
of them give like two nodes, and both of them give very high value, like say 5,000 something, like 1 million, and then you apply softmax to them. Both of them will get 50-50 per 50%, 50% value once you apply softmax, right?
That might not be necessary. That will depend on what sigmoid. So if sigmoid itself outputs like 0.5 for both of
No,
them,
no, no, no. Let's think like if the sigma both value like 6.5, 6.5, the 6.5 and 6.3, let's say 6.5 and 6.3, where there's very little difference between the two outputs, right?
huh,
0.5 is 0.6, let's say.
huh, huh.
The softmax function will increase the difference between two. The 0. 0.6 will get very high, and 0.5 will go low if you apply softmax. But we don't want that. If the multiple objects can be true, we want that if only one of them can be true, like one of them is true and one of them is false. For example, 0.6 is true, then 0.51 is all obviously false. Then you can apply softmax. But if both of them can be true simultaneously, then you cannot apply softmax.
If both of them are true
Yeah,
simultaneously,
both of them are simultaneously true. How do you? Which one will be most appropriate? I don't understand.
Both of them are like the
And
output should be
how
both
come
of
it
them,
is
right?
true? And normally in classification problem, you don't
No,
get both the things simultaneously to be held.
that is
read the question. It's written multiple
if
possibility.
multiple
If
possible.
this was singular, then softmax would be the answer. Because it says multiple, that says softmax is not the answer. Sigmoid is the answer. That multiple is the keyword here.
If it is multiple, right, then why can't 10x or ReLU be the answer? Like if I
The
say that,
10x and value don't give probability distribution. That's why.
so I'll put a threshold like okay, if so sigmoid also will give you a value between like 0 to 1, right?
Sigma is
Yeah,
also a value.
that's
Only softmax will provide you some
So
probability.
it will just tell you that okay, this is 0.5, this is 0.6, this is 0.7, let's say, right? And at
no.
LH will tell, and LH will tell you 10, 20, 30.
Yeah, but 10, 20, 30 are not probability distribution, right? Zero. The probability must
But
always give in zero
so
to
see,
one.
even 0.5, 0.6, 0.7 is not a probability distribution, right? So
It
you
is the
have,
probability distribution of different objects. 0.5 will be probability distribution of that of
but to
possibility
make
of
them
being that.
these are not a probability. See, to make a probability distribution, you have to make sure that they add up to one, right? Otherwise, it is not a probability
No, no,
distribution.
no. Like if there are different events, then they can add up to more than one. If you're talking about two independent events, then they can add up to like two as well. For example, the probability of me of there being a pizza in the image can be zero point 0.9, and then there can be a probability of being a glass of water in the image can be zero point 0.9 as well. Both of them can go more than one,
No, but
right?
then this is not a probability distribution, I'm saying. These are just the probability that it is in image and the image
Yeah,
can.
but 10h is not even giving you that, right? 10h is not even giving you that. 10h is giving you 30.
So
Like, what does 30 means? Like,
then answer me this. If it is 0.5, 0.6, 0.7, and it is
mhm.
a multi-level thing, so how will you tell that glass is in? So let's say I ask you.
Let's say, like,
Let me
uh,
let me just put it simply like this. So let's say you have three labels, right? These are for the objects in the image. So the first one is for glass. Like the first one is for glass, the second one is for knife, and the third one is for plate. So we are talking about the objects that can be on top of a table, right? So there
right.
can be a glass on top of table, there can be a knife, and there can be a plate, and there can be a fork, and so on. So there are like let's say the fourth class is fork, right? Then your sigmoid gave glass as 0.8, this has 0.6, this has 0.6, and this has 0.5, right? Then what will you do? How will you
The
how
probability of glass being there is 80%. The probability of knife being there is 60%. The probability of plate being there is 60%, and the probability of fork being there is 50%.
then what will be
That's
the final output like?
all of these will be output. This is the output.
Then how will you tell which object is there on the table?
I
Because
just said right.
ultimately,
The probability of glass being 80%, that kind of thing.
haha. So similarly, like let's say if I have ReLU, right?
Yes.
Glass, knife, plate, and fork. And ReLU gives me like 10, 5, 3, and 2.
Yes. How are you going to convert it to probability? 10 out of what? ReLU goes from
Why,
0 to infinity.
why do it need to be? Let's say if like here also, if I were to make a guess, what I would then do is put a threshold, right? If it is greater than 0.5, you give it as one,
True.
one,
It will give it as true.
and zero,
Yeah, and 0.
right?
Yeah.
So this is what your final prediction will look like.
Okay. Hmm.
In this case also, I can say that okay, if it is greater than one, or if it is greater than two, you tell that okay, these objects are there. Otherwise, you don't tell these objects are there. Can't it be modeled like that? I mean, that is something that is something like a food for thought, right?
Yeah. I mean, if you're going to use threshold, then yeah, you can. If you're going to
Then the added parameter is like how would you learn the threshold? I mean, yeah, that I understand is a complicated process.
the threshold would be like hyperparameter. So same as
Huh,
learning rate and stuff.
that would definitely be a hyperparameter. In that you can realize from validation set, or you can do simply k-fold cross validation and then you get the answer for the threshold. Like,
Yeah, yeah, yeah. Like yeah, that should not be a big deal.
but I think based on the notion that since we are doing multiple, then I would agree that sigmoid would be the best because it will just directly tell you that okay, this object is more probable than the other object.
Mm-hmm.
In that can be an interpretation because the higher the probability for that particular object, it means that that particular object
Okay,
is more
wait a
probable.
second. Wait a second. For example, in ReLU, you get say 10, right?
Hmm.
How are you going to gradient descend it? What's like the true value? Because in ReLU, the value goes from
Here
0 to
we are not
infinity.
saying that what is the loss function that you are using at the end, right? I can
Yeah,
just
but
like a
how are you
logistic
even going
regression.
to possibly construct a loss function with ReLU? You can't. You need a softmax at the end layer, softmax slash sigma at the end layer.
But why? Like if I have a logistic regression kind of setting, right? Let's say I do a logistic regression.
Logistic regression simply sigmoid will do, na? You have to find out the problem.
No,
Like
sigmoid, along with sigmoid, you might also need a threshold,
no,
right?
you can like just say like for example, grass is actually present.
Hmm.
So you say one, knife is actually present, so one, and the plate is not present. This is like error, and then you can do one minus the probability given by the neural network, and you can do the gradient descent that way. That's the error, right?
Hmm.
You will square and do the gradient descent that way. How
So
are you
what?
going to do that here in the ReLU
Apply
function?
apply softmax on top of Relu.
Then the output layer's activation function is softmax. Like
Softmax with Relu. Huh. So yeah,
yeah,
essentially.
then the output layer of the activation function will be softmax, right? If there's ReLU, and then
हाँ
on
हाँ
top
वो तो
of it
ठीक
you
है
apply
जो फाइनल
softmax.
आउटपुट है वो that will come from softmax so softmax
Softmax.
yes yes
Yes. So because you can't do gradient descent with ReLU and 10H at the outmost layer.
because you can't do gradient descent at the output layer.
You cannot calculate the error, essentially. Because ReLU goes to 0 to infinity.
हाँ वो
The
तो
pop
regression है वो that is a good thing for
that's
regression it is not good for that
yeah.
but I know because yeah.
Yeah, but you can do it in sigmoid and softmax because in sigmoid you can the true you can like the true the ground truth value will become one and rest becomes zero, and sigmoid as well you can just like if the object is actually present in the image you can do one one and zero zero, those are not present, and you can gradient descent that way, calculate error that way. You can't do that in ReLU and Tarrasch because if the object is present you will have to represent it by positive infinity, and positive infinity minus any value is positive infinity anyway, so you cannot do gradient descent.
So what if I keep it like अच्छा even if it is 100 let's say.
What if the value you get from ReLU is 101? You can
Ah,
get like
that is for sure that is for sure. So assuming the corner cases. So for ReLU, it's gonna be max of 0 comma x, and for tan h, it is just the value tan h of x. For sigmoid, it will be a value between -1 and +1, and for softmax, it would be a value between 0 and 1. But yeah, I'm just not getting why softmax is not the answer here.
Yeah, the
So
softmax is not the answer because of the multiple object thing, right?
see, it will not make the other value zero. That's what I am
Yes, it
focusing
will
on.
make the other value zero, sir. That's the thing
Why?
about softmax. If
Why?
one
Why
of them
does
is
it-
very much high, then the other values goes down to zero.
No, why would it make it zero? See, anyways, these are all like, acha, let me just take the example. Okay, so
Let's say like for example, one object gets 0.8 probability,
0.
another object gets 0.9 probability, right?
E to the power 0.8. So what do we get? E to the power 0.8 is this, right? And we divide it, and
By
we
0.8 plus 0.9.
divide it by
It,
e to the power. How do you put to the power? There is no e to the power, right? Can you
yeah, there
find
is
it?
x to the power y, like second column last row, second column last row, second column last row.
Ah, this one, right?
Yeah, you press E, and then no,
Acha.
you
Okay,
made a
okay.
mistake.
And then I do this.
Yeah, now you
The
press
power 0.5.
0.8.
What? Why it is not taking? Acha, let me put it point 8.
Okay,
E to the
it took
power point 8
plus
plus e to the power
zero point 0.9
point 0.9. Okay.
and calculate it, you will get 0.4.
0.7. And that is 0.53.
No, oh, and if you calculate 0.9 thing, 0.9 and you softmax it,
It will be 0.53, right? Because this will be 1
it will
minus
be
that value.
0.53 exactly. As you
So there
see,
is.
like for example, if you say these are probabilities, right? So in
Ah,
first, like the probability that both knife and plate are present is 0.8, 0.9, almost true for both of them, right? And once you apply softmax, the output becomes like very uncertain, close to 50%. Even though before like applying softmax, we were certain that both of those objects are present. After applying softmax, both of those becomes uncertain. For example, that is why like you can never in softmax, if more than one objects go up, ground truth is one. If you like do gradient descent, it will give very big penalty. For example, here both of the, even though the actual penalty should be only very small, like the algorithm is almost correct, both knife and plate are right, but once you apply softmax, the penalty will become very high. Now the penalty is certainly zero point 0.5 for both of them, but even though our algorithm is almost correct.
mhm. And then some mass will also be shifted to, like, if there are some other values like 0.8, 0.9, 0.1, 0.1. So some mass will also be shifted to 0.1, 0.1, and there also the penalty would be there. So using softmax for a single class, single label
Yeah, that works. Single class, single
classification.
label works, but multiple object does not work.
But if it is like the single class of the binary, not exactly single, but like a binary classification, 0 or 1. But if it is like three class classification and single label, still softmax works, right?
As long as the output is only one, softmax works.
Three
If the
class single
output,
level, but if it is three class two level or three class three level, like all of them can be true, then using sigma would be the best option. That is what we have reached to the conclusion.
yeah.
Would anyone else like to? Uh, how many are still there? There's just two of us. Okay. Anyone else who is there? NV. Okay. Softmax होगा, sigma होगा. There are some there are some other also like hinge laws, and so have you heard about hinge functions and things like that? Are you aware of?
No, I've never heard about hinge function. Sorry, what are they?
So that is also like this. So maybe we should go through this. Does it say that incorporates a margin or distance from classification boundary? अच्छा नहीं. So there also it's like a it's good for a binary classification thing. So it's 0 comma 1. It is max of 0.
Okay,
These
okay.
are
So we
like
are
short
just taking the
functions.
maximum.
Uh-huh.
Yeah, but won't this be difficult with differentiation? You can't read differentiation maximum.
Yeah, certainly you can also not differentiate the ReLU. Like ReLU is not
Only
a
at one point, right? Only
ah,
at one point.
so you can also ignore this at that point. But yeah, people smooth out, right? People smooth it out with like max of either I think it is 0.01x or something like that, comma h something. There is a smooth version of ReLU also. Are you aware
Yeah,
of
I'm aware about it. Like, yeah, yeah, yeah. I'm aware. Like, I think the professor even discussed about it. The smooth version of it.
yeah.
Soft plus. Yeah, professor said rectify. Yeah, professor talked about it.
What is the soft plus activation function? It is log of 1 plus e to the power x. No, this should not be the right thing, right? I mean, it should be ReLU.
No, the graph was there. I graph. This is the graph. Yeah,
And this is
yeah.
for
You
the
see
ReLU.
that? Yeah,
Huh?
this like the ReLU and then the other
Green one.
graph is yeah.
The green one. Potential problems not differentiable at 0.
JLU. We are talking about JLU.
Yeah, either you do Rikilelu, which I was talking like 0.01x or otherwise, and then there is GLU. GLU is a smooth approximation, which is f of x equals to x times phi of x and x as differentiation is this.
See, differentiation must be crazy difficult.
So phi x is a cumulative distribution function of the standard normal. Oh, wow.
Yeah, yeah. No, this is
So
computational definition.
1 over root 2 pi e to the power something, e to the power some shit. Yeah, it's gonna be a difficult thing to differentiate. That's why they immediately switched it to CLU. So you do sigmoid of x, and that makes it differentiable. And then there is soft plus, so smooth function approximation to rectifier is ln 1 plus e to the power x. Okay. Then this is so log function is differentiable throughout. So ln 1 plus e to the power x will be 1 plus e to the power x is continuous, so that is also continuous and it will differentiable. Nice. ELU, exponential linear units. So what other topics were covered in this week? Like
The convolutional neural network,
CNN also. CNN,
CNN.
so they cannot even give you a question. These are the kind of questions that they will give. I don't I don't believe like I would be in shock if they ask you to do an iteration of a CNN. That would be like too much.
There's no way, like it would not even it would be like a stupid. How are you even supposed to do it without the computer program? It would be a different thing if we get like a
No,
Python
no.
script,
So what
etc.
I was saying, like they give you a 3 by 3, like a 4 by 4 image, right? A 4 by 4 grid with values inside it. Then they give you filter weights, right?
No
That
way.
is the 2 by 2 filter, and they give you a stride, and then they ask you to find the final output of this convolution layer.
Yeah, no way. No one's doing that.
Nice. Okay, so yeah, this is the next question. If the size of the output image after an input image of size 64 by 64 is passed through a convolution filter of size 4 by 4 and stride 2, followed by a convolution filter of 7 by 7 and stride 1 is d by d. So, what is the value of d? Okay, so I was going through material and I found this like, so let me just expand this out. So if you have W1 H1 as the input width and input height, and your size of filter is F and the stride is S, the final output that you get is equal to W1 minus F plus 2P divided by S plus 1, right? So in this case, the
Oh, this OnePlus is like with S or outside of S?
outside of S.
Outside of S.
So yeah, so first it is going through 4 by 4 and then it is going through 7 by 7. Okay. So since the input image is of size 64, right? So 64 minus 4 divided by 2 plus 1, right? So this is 60 divided by 230 plus 1 is 31. So from the first convolution layer, you get the output of size 31, and then this 31 is fed into the second layer. So that is 31 plus 7, and the size of filter there is 7, and the stride is 1. So 31 minus 7 entire thing divided by 1 plus 1. So 31 minus 7 is 24, plus 1 is 25. So you finally end up with the value 25. Okay. Now, which of these accurately describes ReLU activation over 10H? So it is obviously faster to compute. And then 10H, as you are aware with this problem, that if so basically it is prone to gradients going to zero. So using ReLU actually circumvents that problem, and it reduces gradient
Yeah,
vanishing.
so A, B, and D, right?
And ReLU is a continuous function, is obviously
No,
wrong. That
false.
does not saturate at high value. That is also true.
Okay, A, B, C, D, A, B, C, D. Okay, allow them.
A, B, and D. Yeah. ABD. Now consider a neural
No, no, no. Wait a second. ReLU is a continuous function.
ReLU.
ReLU is a continuous function, but not differentiable.
अरे हाँ.
Like, there's no break in
No,
ReLU.
no, no.
एक second.
Why do you say it is continuous? Because it is zero, and then from zero it
No, no. That's
it's a
the
ramp
definition
thing,
of
no?
differentiability. ReLU is continuous.
एक second. Is ReLU continuous?
And every continuous function is differentiable, na?
No, 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 no. Continuous means that there is no break. So never like putting
Every
a pen up.
differentiable function is continuous. That's what the theorem says. Every continuous function is differentiable. I would not. Is ReLU continuous? What does the professor says in the class?
No, he doesn't say anything about this.
Then okay, that is something. So ReLU
Yeah,
is a
ReLU is
continuous function,
continuous.
meaning it is differentiable anywhere other than the zero. And the value of derivative of zero can be arbitrarily chosen to be zero or one. The output from ReLU is unbounded in positive domain and can continuously grow in
Yeah.
size.
So why is C not true?
Is this advantageous over 10H? Like
No, not the
so
advantage.
we accurately describe ReLU. But then why is this even a point here? Like is 10H not a 10H is not a continuous function, right?
No, tanh is not a
No,
continuous
10
function.
is
Tanh is breaks at plus one.
Also because it goes like minus infinity to infinity, then there is a break, then minus infinity to infinity, then there is a
Yeah, so
break.
C should be right. Right? C should be right.
Tennis is a continuous function, should be right. Even faster to compute the tennis भी तो compute कर ही सकते हैं.
No, actually, if you
really
decide a
okay.
differentiate tanh, you get sec square h, and like you have to do that. ReLU is very
No, no.
straightforward.
See,
If it's greater than one,
differentiation of 10h is 1 minus 10 square h.
yeah, yeah, but like on ReLU is very zero, right? As straightforward, right? If it's negative, then the differentiation is zero. If positive, differentiation is one. So clear. Like,
अच्छा, so computing 1 plus gz square is a
yeah, exactly. Like even then, you're not actually doing this sec square h, right? Nothing like
Actually,
that.
computing 10h of x would be expensive, right? Because ReLU of x is just x if it is greater than 0. But actually computing e to the power 2x plus 1 over e to the power 2x minus 1, that would be an expensive operation compared to ReLU. It is not
Yeah,
that
exactly.
faster to compute the gradient, it is just faster to compute the derivative. It is just saying faster to compute, which I can digest. Like, okay, you're just saying that if it is greater than 0, then take that value. If it is less than 0, then take 0. It's fine.
Yeah, but why is C not true?
Actually, it's a differentiable function, and the ReLU activation over 10H. Activation is, but why are they saying that ReLU is a continuous? Like this property does not even is not a point of comparison. Like
I mean, it
No,
is
no,
kind of
over
right. You
value
if
activation
certain
over
function is
tanh. It's asking, na?
Over 10 is continuity. So what will you get by comparing the continuity? Like
I
that,
mean, if certain function is continuous, like even if the derivation is not defined, you can still like assume. Like if it is
that I agree.
discontinued, like it doesn't even make sense to like define it. You know?
No, but my point is even one step back. Like why are they even putting this option here?
Yeah, I
Why are
don't
they
know.
asking like ReLU is a continuous function? Like because you should be comparing what is comparable. Like just because it is continuous, so what part does it adds to the to the computation or to your I mean, see, gradient vanishing, it is already taken care of.
No, no, actually tan H is continuous and ReLU is continuous. So
Tanh
No,
is
no,
not
tan h
continuous.
is not
It's not
continuous.
continuous.
Tan h is breaks at infinity,
Eight
like
second, let me
pi.
see. Let me see. Tanh is continuous. No, tanh of x would be is we can prove continuity of tanh. It would be we can prove the continuity of tanh by writing it simpler form of fraction is continuity
If
is
you
one.
look at right, it says that why tan h x is
Tan
not
x is
continuous.
not, as I said, it is tan of x, right? It is not tan x. Tan of x is continuous function. No? True
It
that.
says tan x is continuous as well.
तो ये मैं इसलिए तो मैं that's what I am
no,
saying
no,
that why
both are continuous. So why? I mean, it doesn't have anything over it, no? Over the other. So both are continuous means as far as continuity is concerned, why? How come one is over the other?
tan of x बोल रहा हूँ मैं क्या कर रहा है और इसने tan of x is a continuous function prove कर दिया
I mean,
right
I thought like the tan of h is always breaks at pi.
no अच्छा let me see uh, do we have done Wolfram alpha okay let us just plot tan of x right here it can tell like plot tan of x what does it say
Okay, this is pretty clearly
this
continuous.
is continuous right
This is continuous.
इसमें और सिग्मोइड में फिर दिक्कत क्या हो गई
The sigmoid and the gradients are not gradients get saturated at plus one
no
plus infinity and
वो
minus infinity.
that is see gradients get so,
No,
but
but why do you say it is discontinuous
why
as
is
far as
this
tan H is concerned?
why is this a point of discussion when we are comparing the two functions is my question like ReLU is a continuous function ठीक है sigmoid is also a continuous 10h is also a continuous function sigmoid is also a continuous function but accurately describes I think it should be advantages of ReLU over 10h like
Yeah,
are we
this is
comparing
a stupid question. Let's move on.
that's what I was thinking like why is that even here so this one, consider a neural network that performs the following operation. H equals to wx plus b, y equals to exponent of h, and j equals to sigma y I squared. Okay, sigma I y I squared, where x belongs to this, and exp is the element-wise exponentiation. Okay, and then which of the following is the represents the derivative of j with respect to the bias term. Okay, so we'll do that. No problem. Right. So they said that they are saying that some z equals to wx plus b, y equals to exp of z, and j equal to summation over I yi squared, right? So how we will go from del j to del b? We would do del j by del y by del z, and then del z by del b. That is how we will compute, right?
Yeah, the changes.
Del j by del y it is 2y, right? Del y by del x is y. Del y by del z is y because it is exp of y. and del z by del b is 1. So you'll get 2i into y. And that's what this is saying there.
So
This one,
B option.
y. Yeah. Now, which of the following statement is true? So I think this was discussed in the class, right? Fat plus short neural networks can theoretically compute all possible functions provided enough neurons are
Yeah,
available.
yeah, A is true.
इनकरेक्ट पूछा है अच्छा ठीक है तो ये तो ट्रू है देयर इज अ सर्टेन क्लास ऑफ कंटिन्यूस फंक्शन दैट कैन ओनली बी कंप्यूटेड दिस वन इज obviously incorrect because ultimately
False.
they both realize for the same number of parameters we should prefer tall plus thin over fat plus short ones
Uh, True. I think true
for the same
because the
number
prof.
of parameters we should prefer tall plus thin over fat plus short it does not matter whether we choose tall plus thin or fat plus short now why
Yeah,
what
this was discussed by the professor.
Acha. What was the argument made? Can
The
you?
argument made that when you have like a tall network, it is possible for the neural network to have like abstraction, layer of abstraction at a time. For example, at one if like trying to detect a face, the lowest level can be like very edges and above straight lines and things like. Then second layer can do curves. The third layer can do like eyes and stuff. Then fourth layer can like rearrange those eyes to make sense of faces. That kind of thing. You can't do that with five fat layers. In fat layer, everything happens at once or does not happen at all. So like when you try to train a fat network, you will not be able to. But when you are the deep networks can be tall thin networks can be trained.
Acha. So the tall refers to the width of the network,
The depth of the network.
the depth of the network. So you know the concept, right? What is depth and what is width, right?
Yeah, the width which is like the number of parameters in a layer, and like the depth would be
Hmm.
total number of sequential hidden layers.
Hmm. So when we are saying it is tall and thin, so we are saying that what are we saying?
There are few parameters in one layer, but there are many hidden layers.
अच्छा हाँ ठीक है then obviously choosing tall plus thin over fat plus short so fat means that there are a lot of hidden neurons.
No, no. Fat means that there are a lot of
Yeah,
parameters in one layer, but
There
there
are
are
a lot
few
of hidden
so
layers.
neurons.
parameter. So here parameter is. Do you mean it's number of neurons? I think it's thin or fat. It depends upon the number of neurons. As far as tall is concerned, it is number of layers. Is it like that?
The number of parameters is the number of nodes in one layer.
Yeah, that means neurons.
Yeah,
If we have a
one
fixed
neuron
number of
in one layer.
parameters, why should we not train fat and short? We should learn a. Acha, it is saying fat and short.
Yeah, fat means I think is it number of neurons in a particular layer is used.
Yes, yes, yes.
Yeah.
Just what in there and fine. So why should we train a thin and tall neural network, which would be deep? Let us be shallow. Let us be fat, depending on what we are playing. Sumo wrestling or basketball. The slide you just showed could begin an approximation next with just 10 layers. Since when you talked about increasing layers, why do we have a concept of do you know this theorem is only for one hidden layer? What happens when you have many layers? Do we have a bound? Do we have theoretical results which tell us okay, these many layers? I will tell you the trick here. The theorem is representability. It is not learnability theorem. It says that a continuous there is some set of parameters that can realize this function. It does not say that those parameters can be learned by propagation. Now, what happens is when you start to learn a big fat network in the hope that a bit shallow is going to realize what we are looking for, we do not usually succeed. For why that happens, you can be famous, you can prove a theorem in this. Of course, theoreticians do not become like philosophy. Acha, so what? So what I would say, so fat is the number of
But
hidden
here
layers,
is the
right?
reason.
No, 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 sir. The fat is the number of parameters is one layer.
So that is like, so the fat is the width and short is depth. That is what you are saying.
Yes, yes.
Deep means it is number of layers. If
No,
the
no, no,
number
no,
of
no.
Yeah,
layers
yeah.
is
Deep means
known,
number of
means it is
layers.
deep. Yes, deep is number of layers.
Deep
And
is
this
number of
results
layers.
also, what has been shown in that slide, that also tells. I mean, this 1K, 2K kind, the table, yes, this one.
So layer into
The
size.
first one is layer one, and size is number of neurons in that layer is 2K.
So this would be a thin plus tall, right?
No, no. This would be short. This would
This
be
would
like
be fat
seven
plus
layer.
short. This would be fat plus short, right?
Yeah.
So number of layer is one and size of each layer is 2K.
No, no, no. This is tall, thin plus tall.
No, no, this is because you are saying
No,
that
no. This is the first one is thin plus tall, and second one is for short and fat. Think
this.
about it. Like number of layer is the depth, right? There are seven layers, so there is a depth equal to seven, and the number and the size is the like the fatness. So like 2K fatness and seven layer depth. In the second, I mean the in the second the third column thing, the depth is one. So it's like a very shallow network, and the size is crazy like 4,000 something 16K. So like this is like a fat and short and fat network.
So 1 by 4634 is a short and fat neural network.
हाँ.
हाँ ठीक है थिन प्लस टॉल मतलब thin plus tall means the width is
Less, but the depth is high.
less but the depth is high. So how it is tall? Like it is
The tall and depth are the same thing, right? If something has depth of very depth, then it is high. Depth and tallness is like the thing of perspective. If you are at the top, then thing is deep. If you
so
are at the bottom, then thing is tall.
what I am what I was a bit confused is say if I am saying thin plus tall, okay, what I would draw intuitively if I were to say thin plus tall,
Yeah, yeah, yeah. You just rotate it
I would
90
draw something
degrees.
like this, right?
Yeah,
But in theory, this is fat plus short.
yeah,
And if I were to draw fat plus short, I would draw something like this.
yeah. It's like the you rotate it 90 degrees and like
So for me, and in this is thin plus tall.
yeah. This is thin plus tall.
And I think the reason would be that you do weight transpose. That's why it is like this.
No, it's actually just the perspective of like where the inputs and outputs are. If the inputs are at the bottom and outputs are at the top, then and the like this will completely change. Like if the inputs are at the left and the outputs are at the right, it's just a matter of definition and perspective. It doesn't even matter.
X into W or W transpose X. Yeah, if you even, but normally Acha. So have you, if you have taken entry Vengeance class, right? Then
Yeah,
you
yeah.
might know this like that the how we configure X, we write W, right? Because depending on that, if the feature matrix how it is defined, either you define feature matrix like x11, x21, x31 like
Mm-hmm.
this, or you define like x11, x12, x13. So these are like exact transpose of each other.
Yeah, no, like the transpose will get like flattened out.
No, no, no.
There
I'm
it
saying
will
like
be row
okay,
wise,
Okay,
column
yeah, I
wise.
got it. I got it. Yeah, yeah, these are transpose. Like fine, fine, fine. I got it.
right. So that's
Yeah.
that's why since the weight matrix is taken as transpose, that's why this is called thin plus tall because its transpose would look like this, right? Its transpose would be thin and tall.
Yeah, yeah, yeah. Hmm.
Although this metric this looks like fat and short, its transpose would be thin and tall. And similarly,
Hmm.
this one is thin and tall, but its transpose would look like fat and short.
Yeah,
That's why they
yeah.
are named like that because of this W transpose X.
Hmm.
ठीक है, now it makes sense. So for the same number of parameters, it does not matter whether we choose tall plus thin or fat plus short ones. हाँ, ठीक है. Because if we have more depth, then we can realize at each layer a particular layer of abstraction, like you argued. Then it's now consider the multi-layer perceptron. Okay, so copy. Let me just copy this. Acha, even before this, let us solve this question and then we will. In an MLP, all weights are initialized with 0, then the output of all units in the output layer is equal. Now, using mean pooling in CNN does not increase the number of parameters. So, the statement 2 is correct, right? Because pooling layer does not have any weights associated to it. You just pool in that particular region the uh,
But isn't like the number of cells you consider for pulling a hyperparameter?
no, no, it is saying that using mean pooling does not increase the number of parameters,
Y-
right?
Yeah, but mean pooling does increase the number of parameter, as in the number of cells you are considering for like mean pooling is a parameter.
That
No.
are the learner. No, no. So essentially, what it is saying is if you have the parameters that are to be learnt is W.
Yeah, fine, fine. The okay, so the size of the mean pooling is would be hyperparameter.
Right. So that does not increase the number of parameters. Like, but if you were to add another filter or if you were to add another convolution layer, then obviously the number of parameters would increase, right? Or if you drop
Yeah,
one,
yeah,
then the parameters would decrease. But if you keep on adding pooling, the parameters won't change, right? And the statement
yeah.
was in MLP, if all weights are initialized to 0, then the output of all units in the output layer is equal. What would you say about it?
Depends on the
That is
bias.
correct, I think.
If
That
the
is
bias
correct.
is
If it is saying that all weights, so consider bias also.
no, no, weights
It's
and
not
bias are
zero
different
now.
things, right?
It doesn't say anything about bias.
Yeah,
So
so
it
if
will
the
be zero
like
only.
we say like weights and biases, right? So like
I'm just
bias should
saying
not
that
be.
assume that for now, let
Now,
that.
how I'm going to know in the exam, like whether the question is asking if weights are included in biases or not?
Yeah, because at the time of teaching, they tell you that it is WX plus B. So, but
It's not
but
necessary to.
when it is saying, see, but when it is saying like the weights, all weights, so it would mean that
No, no,
all.
sir. Most of the
Acha,
questions also it is clearly mentioned that weights and bias initial all weights and biases are zero.
acha,
Or
here if I
I'm
say if
saying
all
most of the
parameters are initialized to
Yeah,
zero,
then I agree with you. Then the question is right. Yeah, yeah,
no.
all parameters, but the parameters word is not even mentioned in that statement.
yeah, because only then it would be equal. Otherwise, it will not be
Yeah,
equal.
yeah, yeah. Only with all parameters are mentioned, then it will be equal. Otherwise, no. If the weights are different, biases are different, then the value can be different as well.
So let's do a dummy run, right? I mean, if you have time, we can just see like, so this is like so we have two inputs, right? And then we have this, and then we have this. Let's do a very simple thing. So let's say the
X1, X2 input.
this is x1 x2, right?
Which are zero.
Which
W1
no,
and
no, which are
W2
not
zero.
zero. The input is not zero. The
Yeah,
weights are
X1,
zero.
X2 will not be zero.
Which will
Okay.
eventually become zero, right? And the bias at this layer, it is 5 and this is 6, right?
Yeah.
And we have and then we have two outputs, so this and this, right?
No, then it would make then no, no, don't do that. Just connect one layer.
No, no, it's
No, no,
they
just
are not.
connect one.
The output of all units in the output layer is equal. That is what we want to see, right?
No, no, but where is it said like the output layers connected to
Chalo,
all
theek
the
hai. Okay,
previous
okay,
layer?
okay. I understand your point. Okay. Now I'm saying that let this be an intermediate layer. Chalo, let this be an additional intermediate layer. अच्छा let keep the connection simple, let not complicate it, ठीक है. इधर 5 है, इधर 6 है, and then we are claiming that यहाँ से it goes here and from here let's I'm just doing that, it does not make sense whether, ठीक है. So what will be the output at this particular layer?
This will be 6.
No, the weight is 0, right? The
Yeah,
weight
yeah.
is
So
0.
weight is 0, then x2 will be 0.
तो यहाँ पे का,
And
and also we also need to consider the biases here also, right? So this is
yeah,
b1,
so the 6 plus v1.
so 6 into 0 plus b1, right?
Yeah, 6 into 0 plus b1.
And that will be 5 into 0 plus b2. So now when these are also 0, they will be equal. Otherwise, it will be B1 and B2.
Yeah.
B1 and B2. They have not commented on biases, right? When the output of all units in the output layer is equal, it should be if all parameters are initialized, then it would be a more correct statement.
The thing is like,
Yeah, I understand your point. It should be all parameters. It has happened before also that they say something and then when they evaluate it means something totally different. Okay, so we have this one and we will, so I'll just label this node as Z1 and this node as Z2. Okay, and I think all the biases are zero. Have they specified it? So consider the following perceptron. The number on represents edge weight on the input number, and so biases are not given. So let us consider them zero. So Z1, Z2.
no,
Acha, these are the
biases are
biases
not
only.
given.
Bias is the threshold. So these are the thresholds, right?
Hmm.
1 and 1.5. So if it well, like, was it discussed in the lecture why the concept of bias was introduced and
The bias was introduced to like change the intercept, y-intercept.
hmm,
You cannot change the y-intercept without bias.
hmm,
If you make a graph xy
hmm,
with weights, you can only change the gradient.
hmm,
You cannot move the line up and down.
Acha. So this concept of how bias it can also be interpreted as a threshold or something was not discussed. Like,
No, no, nothing like that. Bias is not the threshold.
nice. Then you might want to look into that. It was a good thing that like it was an interesting thing. So essentially, like threshold becomes a hyperparameter, right? So why and it gets triggered only when we have a value greater than a particular threshold, right? So
Hmm.
then what they thought is like, okay, let's put bias that will essentially act as a threshold, and then
Oh, okay, yes.
let that be learnt as a part of a training process instead of putting that as a hyperparameter, which made things untractable if this were like a very big network.
Oh, okay, okay. So it's like a ReLU with.
Hmm.
Okay, so like once you create threshold is basically ReLU with bias.
Exactly. Threshold ReLU is like a threshold with bias. Okay, anyways, let us compute this question. So since x1 and x2 can be binary inputs, so I'll just keep them 0 0 0 1 1 0 and 1 1, right? So for these values, what will be the value of z1, right? So value of z1 will be minus 2 times 0 plus 2 times 0. So this will be 0, and since it is less than 1, the final output will be 0. In the second case, it will be minus 2 times 0 plus 2 times 1. It is 2, which is greater than 1. So the label that we get from here is 1. Then it is minus 2 times 1 plus 2 times 1, which is equal to minus 2, which is less than 1. So we get 0. And this is minus 2 times 1 plus 2 times 0. And this is equal to 0, which is less than 1. So from here we get 0. So these are the values of Z1. Then,
Multiply by them too.
yeah. Then for Z2, we have Z2 as X2 plus Z1, right? So X2 plus Z1, X2 plus 2 times Z1. So this is 0 plus 2 times 0 plus 2 times Z1. So this is 0 plus 2 times 0 plus 2 times Z1. So this is 0 plus 2 times Z1 plus 2 times Z2. So this is 0 plus 2 times Z1 plus 2 times Z2. So this is 0 plus 2 times Z1 plus 2 times Z2. So this is 0 plus 2 times Z1 plus 2 times Z2. So this is 0 plus 2 times Z1 plus 2 times Z2. So this is one. And then we have oh, did I
Yeah, you
drop? Did
dropped
I
actually.
drop off?
Yeah, you were disconnected.
Okay. Okay. Yeah. Uh, okay. I hope I'm visible. I'm audible now. Yeah. So when did I get disconnected? I mean,
Like, doesn't
I
even
was not.
matter. Like, I'm following.
uh, Okay. So then this becomes 0 into 1 plus 0 into 2, which is 0, which is less than 1.5. So this is 0. And then this is 1 into 1 plus 0 into 2, which is 0, which is less than 1.5. So this is 0. So what is the truth table that we got? So we got x1, x2 as 0, 0, 0, 1, 1, 0, and 1, 1, and y we got as 0, 1, 0, and 0. Now, what are the options that you have? So, are we realizing x1 and x2? No, because at 1, 1 it is 0, and at 0, 1 it is 1. So, no. Are we realizing x1 or x1 or x2? Definitely no, because at 1, 0 it is 0, and 1, 1 also it is 0. Then are we realizing x1 implies x2? That's a good question. So that would mean not x1 or x2. So no, we are also not doing that because when both are 1, this is 0, which should not be the case. And then are we realizing not x1 and x2? So not x1 and x2. So 1, 0, 0,
Yeah,
1,
this is true.
0, 0, 0, and 0, 1, 0. So yes, this fits this option. And that would be all.
So, sir, like, in the meantime, like, before, are you going to be taking classes before exams?
So I think 21st would be the last class, right? After that, no class.
Okay, so no class at 28th.
I mean, we were told to do 12-week session, and I
Okay.
think this 21st would be the last session.
Okay.
Mm. So, like, even if we do an extra class, what would we discuss there? Like,
I don't know. Like, if we have some certain question, maybe we can talk to you about that.
that we can do in the last class itself, right? Because the 28th and the 21st one would be would there would be no next week topics to discuss, right?
Mm-hmm.
That would essentially be the doubt clearing for week 12.
Right.
Or will there be a class on 21? Let me see. So one, 2, 3, 4, 5. No. So there are 3 weeks in April, right? No, 2 weeks in April. Then there is 1, 2, 3, 4, 5 weeks in March. 2 plus 5, 7. And then there is 1, 2, 3, 4 weeks in 7 plus 4, 11. So we started Feb 3, right? So yeah, so there will be one more session that will be on 21st. And that would be the last session. And your test is on 29th or 30th, right? Something like that.
Yeah. 29th.